you're going to find that division of fractions is very similar to multiplication in the sense that the y part takes a moment to see. Once you see it, it makes a lot of sense. And then the process itself is really straightforward. In other words, it's just a couple of steps, nothing else. What I'm going to start out with is 1/2 divided by 1/4. And as usual, I'm going to use a picture. So I made something and highlighted half of it. What 1/2 divided by 1/4 means is how many fourths will go into 1/2. So if I take my same picture and I divide it up into fourths, you can see there's 1, 2, 2/4 and 1/2. So the answer is 2. Now it would be great if I could just draw a picture like this for every type of problem, but as usual, it's nice to see the picture. It helps you understand it. You can always draw a picture, but it's not going to be as nice with other types of fractions. These are both very easy to see. But again, look, what all I had to do was divide it up into fourths and say, well, how many fourths are in there? I can see right there, there's 2/4 in there. Well, what if I had something like, I don't know, 1/9 over 2/10? That's going to be a lot harder to draw the picture of. I'm going to start off with a rule that's true, and we're going to use that rule to see how we find that type of division without a picture. The first rule is that a over b times b over a is actually equal to 1 no matter what fraction you have. If you're not sure that this is true or not, cancel out the a's. Their share, you cross cancel. You would get 1 and 1. Cancel out the b's, you would get 1 and 1. This is actually because they're reciprocals. In other words, b over a is called the reciprocal of a over b. So if a over b was 1/3, this would be 1/3 times 3 over 1, you get 1. So anytime you multiply a fraction by the same fraction flipped, you get 1. All right, now if you're wondering who cares, that's fair enough because we haven't shown what this is used for. Let's take a division problem. 5/8 divided by 3/4. So this is what I was talking about. This would be pretty tough to draw a picture of. We could, but it would get so complicated it would ruin the idea of trying to understand what's going on. I could actually write this as a fraction. Remember that fractions represent division. So 5/8, for instance, means 5 divided by 8. So if fractions represent division, this fraction, which is called a complex fraction, represents the same thing, 5/8 divided by 3/4. Now, if I wanted to simplify this, I would love to have this over 1 because, for instance, 5 over 1 is 5, so anything over 1 is just whatever the numerator is. Well, okay, 5/8 divided by 3/4. What if I multiply that 3/4 by 4/3? It's reciprocal. Well, anytime I do that, I get 1. That's what the rule before said. But remember when we were simplifying, I said you can't do something to one part of the fraction and not the other, so I got to multiply by 4/3 up here as well. When I do that, at the top, I have to do 5 times 4 is 20, 8 times 3 is 24. On the bottom, that's going to be 1, and anything over 1 is just itself, so this is 20 over 24. This is 5 over 6 when you simplify. Now this is definitely a complicated process, and I'm not saying that this is what we're going to do every time, but it's going to show you why the next rule is true. To divide two fractions, you multiply the first by the reciprocal of the second. You may have heard the phrase flip and multiply. So when I have 5 over 8 divided by 3/4, I leave the 5 over 8 alone, and I flip the 3/4 and I multiply. That process I showed you a minute ago is the reason that this works. Because if we had a 3/4 in the denominator, this would just cancel it out basically. Now I can multiply as usual. I'm going to multiply straight across. I get 20 over 24. Simplify, I get 5 over 6. So to divide two fractions, you flip and multiply, flip and multiply. And the reason is for that, complex fraction I showed you before. All right, so as usual, a couple of examples. Let's see how this works. So I'm going to leave the 1/8 alone and flip the 1/2 into 2 over 1. Now I multiply straight across. 1 times 2 is 2. 8 times 1 is 8. This simplifies to 1/4. Now I can actually simplify the same way I did with multiplication before once I get to multiplication. We're doing what mathematicians do a lot, which is reduce it to a previously solved problem. We learned how to multiply. Well, now we've turned it into multiplication. We've taken division, this new thing, and we're looking at it from the perspective of multiplication. So 5 over 6 divided by 9/4, leave the 5, 6 alone, flip the 9 over 4. Now it's 4 over 9. So instead of like before where I simplified at the end, I'm going to treat this just like any multiplication problem and say, okay, 5 and 9 don't share any factors, but 4 and 6 do. So I can cancel out the 4 and get a 2, take a 2 out, do the same thing with the 6, I'm left with a 3. Now multiply 5 times 2 is 10, 3 times 9 is 27. All right, the last problem, 2/3 divided by 7 over 20. Leave the 2/3 alone and flip the 7 over 20. I get 20 over 7. 2 times 20 is 40. 3 times 7 is 21. No factors are shared, can't cross-cancel anything. So in the first one, I could have cross-canceled the 2 and the 8, and I would have gotten 1/4, one less step. So it's up to you. It's just like a multiplication problem once you flip and multiply. Now, same question I asked at the end of the last video. What about whole numbers? And it's the same answer. You can write a whole number as something over 1. So 2 divided by 3/4 is actually 2 over 1. Now flip the 3/4 times 4 over 3. That's 8/3. 5 over 8 divided by 3. Well, I'm going to rewrite this first. This is 5 over 8 divided by 3 over 1. Now I'm going to flip that 3 over 1 and multiply. So I end up with 5 over 24. As you can see, it works the same way with whole numbers. So with division, flip and multiply. If you remember that phrase, you'll be fine.